Okay, today we're going to learn about the graphs and applications of logarithmic functions. So the very first thing that we need to learn today is how to sketch graphs of the logarithmic functions. Logarithm x to the base of a, or y is equals to ln of x. Ln of x is also logarithm of x to the base of e. And we can also learn how to use logarithmic functions as models. So now the two values or the two graphs of logarithm x to the base of a, there are two different ones. First and foremost, just take note that the value of the base a cannot be equals to 1, and the value of a must be greater than 0. So now when the value of a is greater than 1, what happens is that we have a graph that looks like this. So y increases as x increases, so it will increase this way. Similarly, okay, when we have the base, okay, of the logarithm is lesser than 1 but still greater than 0, it will decrease as x decreases, and the shape of the graph will look like this. Notice for both of these graphs, they will approach but never touch the y-axis. That's number one. And number two, they will both cross the x-axis at the value of 1. Okay, so just to give you a hint, okay, just to show you how they're related, actually they are mirror images of each other. So if you draw, okay, y equals to e to the power of x, okay, this is the graph. This is an exponential graph that we have learned in 5.2. And this is y equals to ln of x. Again, it doesn't touch the y-axis, but it's like a mirror image. Can you see that this and this and this and this, the distance are equal? So this is the mirror, and y equals to e to the power of x, y equals to ln x. They are the mirror images of each other. Okay, now what I'm going to do is to draw to sketch the two graphs for you. Y equals to logarithm of x to the base of 3. So in this case, what I'm going to do is, first thing that we notice is that the base is 3 and the base is larger than 1 itself. So when the base is actually larger than 1, okay, what we will have is, okay, so the base is 3, which is larger than 1. So that means that y increases as x increases. Hence, the very quick sketch of the graph, okay, will look like this. And then here is equals to 1. And you can label this y equals to logarithm of x base of 3. For b, similar, alright, in the sense that, but now if you notice, the base is 0.5. So 0.5 is less than 1 but greater than 0. That means y decreases as x increases. So what happens here is we get a graph that looks like this. This value is 1. Okay, just take note that both intercept the horizontal axis at 1. And next thing is it will approach but never touch the y-axis. Similar from the first one that I showed you, it will approach but never touch the y-axis. So be very careful when you sketch these. So now try 25. Please sketch these two graphs. Log of x base of 1/3, logarithm of x to the base of 5. And when you're ready, okay, just pause the video first. And when you're ready, please unpause the video, and then you can see how the graphs are drawn. In 3, 2, 1. Let's go. Okay, for a, the base 1/3 is lesser than 1. Hence, as x increases, y will decrease. So it's a decreasing function, it's downward, okay, and it will intercept the horizontal axis at 1. And notice that here it approaches but never touches the vertical axis. Similarly, logarithm of x base 5 is greater than 1. Hence, as the x value increases, y value will increase. So what we get is logarithm x of base 5. And same thing, it will intercept the horizontal axis at 1. Okay, those are the graphs. Now we talk about example 26, where we have application of the what I call the logarithmic graphs. Okay, or we have applications of logarithms rather. So in chemistry, pH measures the acidity of a solution. So it's given by negative logarithm of H plus, okay, to the base of 10. So first and foremost, okay, they will ask you where the hydrogen ion concentration in moles per liter. So that's what H plus is. So they say that tomato juice has a hydrogen ion concentration of 0.001. So in this case, what I can do here is simply, okay, to apply pH is equals to negative logarithm of 0.001 to the base of 10. Okay, in your calculator, it will be known as Lg 0.001. You put a negative in front. You just key that into your calculator. You'll find that the pH of tomato juice is equal to 3. That's pretty acidic. Okay, now part 2 is this. They tell you that the pH of lemon juice is 3.5. So what is the hydrogen ion concentration in mole per liters? So we need to solve, okay, an equation that has logarithms. So logarithm of H plus to the base of 10, negative of that, is given by the equation here, is equals to 3.5. So for us to start solving this, what I can do is express a logarithm on the left hand side is equals to negative 3.5. I hope you remember how to change from the logarithmic form into the index form itself. So if I do that, so the value of the H plus, okay, or the concentration rather in this case, is 10 to the power of negative 3.5. Solving it, what you get is 0.000316. So that in itself gives me 3.16 times 10 to the power of negative 4 mole per liter. And move on to part 3. If the lemon juice is diluted by a factor of 10, how will the pH be affected? So earlier we know that the pH of lemon juice is 3.5. So now what I'm going to do is this. I get negative logarithm, okay, base 10. So earlier, okay, we found that the if you notice, the concentration of the lemon juice itself is 10 to the power of negative 3.5. So I will say that this is 10 to the power of negative 3.5. But now in this case, what I'm doing is that the lemon juice is diluted by a factor of 10, which means that the concentration is divided by 10. So once again, this was the concentration that we obtained from part 2. We are dividing by 10 now because we have diluted it by a factor of 10. So it's 10 times less potent. So put a bracket here. If you use your calculator, you have to key in, okay, you get negative logarithm base 10. Okay, you key this into your calculator, you find that the pH is equals to 4.5. So initially, the pH was 3.5, now it's 4.5. So the question is, how will the pH be affected? It has increased, okay, by 1. So the pH now is 4.5, up from 3.5. Okay, if you're ready, you may try something similar. This is try 26. All right, please pause the video, take out a piece of paper, look at on your iPad, okay, and give 26 a go. And I will carry on in 3, 2, 1. Let's go. Okay, first for try 26, they talk about the pH of blood is about 7.4. What's the concentration? So I simply substituted the pH to be 7.4. Okay, then we express it as negative 7.4 is log of H plus base 10. From this step to this step, we have changed from the logarithmic form into the index form. I find the hydrogen ion concentration is 3.98 times 10 to the power of negative 8. For part 2, a solution with pH less than 7 is called an acid, and a solution with a pH greater than 7 is called a base. So now, black coffee has a hydrogen ion concentration of 5.1 times 10 to the power negative 5. Okay, the answer here is presented as such, but if you want, inside your calculator itself, actually what you can actually input in your calculator is this. You open the bracket, you key in 5.1 times 10 to the power of -5. You close the bracket, you do this and you should be able to get a 4.9 as well. Okay, in this case, we're not answered the question yet because they ask you, what is the pH level? Is it an acid or the base? Since 4.9 is actually lesser than 7, so it's considered to be an acid. Part 3, if the black coffee is diluted by a factor of 15. So what I'm doing here is I will take this and divide it by 15. So what I'll get is, when you key into your calculator, so you can key negative log, 5.1 times 10 to the power of -5 divided by 15. You should be able to get a value of 5.47. So initially the value was 4.29, now it's 5.47. Hence, if you take the difference, you find that the pH has increased by 1.18. Example 27 again deals with chemistry. So logarithms, right? Actually, we can use it quite a bit in chemistry. In reality, we actually use logarithms to actually measure earthquakes as well. So it's something that's quite common, right, in the measurement of earthquakes. So, okay, we start now with this example 27. So what is the temperature? Okay, so the temperature is given by this equation here. So what's the temperature after 10 minutes of heating? So the theta is 10 plus 15, 2.4, T is 10 over 8. So if you input that in your calculator, you find that the temperature, correct to 3 significant figures, is 54.8 degrees Celsius after 10 minutes of heating. Now, in part 2, how long will it take for the temperature to reach 80? Okay, so now right, we have to do some solving here. So I will say that 10 plus 15, 2.4 T over 8 is equals to theta. So notice that theta now, okay, the value of theta itself is actually equals to 80 degrees Celsius. So I'm just going to go right ahead, erase this, and fill in the value of 80. Okay, I know that when there is a value of t there, in order for me to, in a way, extract the t, I can take logarithms on both sides of my equation. But please be very, very careful here, okay, before you do that. So you have to leave just one term on the left-hand side first before you apply logarithms. So what do I mean? Let's do it step by step. First, I will attempt, okay, to resolve this value of 10 here. So 15, 2.4 t over 8 is 80. I minus 10 on left hand side, minus 10 on right hand side. I'm left with 70. Then don't resist the urge to take logarithms now, okay, because okay, there's a 15 still there. It will become messy if you take logarithms now. Logarithm 15, logarithm 70, then you have to actually separate them out to logarithm 15 plus logarithm of 2.4 t over 8. Not so good an idea. So it can be done, it's still mathematically correct, but I suggest to you, right, to resolve the 15 first, and it makes your life a slightly bit easier. So to make your life easier, we divide by 15, divide by 15. I eliminate the 15. So what I do here is I'll get 2.4 t over 8 is 70 over 15. Now, if you want to apply the logarithms on both sides, you can. There's only 2.4 to the power t over 8. So take logarithms here and logarithms here. So I take logarithm 2.4 t over 8 is logarithm of 70 over 15. Then what I can do here is this. I can apply power law. Here t over 8, okay, it becomes t over 8 is equals to t over 8, sorry, multiplied to logarithm 2.4 is logarithm of 70 over 15. So I continue to solve. T over 8 is logarithm of 70 over 15 divided by logarithm of 2.4. Finally, we're almost to the end here. You multiply by 8 on the right hand side and left hand side. What I'll get is t is equals to 8 times of logarithm 70 over 15 over logarithm 2.4. One shot, you use a calculator. Please really do try, okay, to get this. You will find that the t value is 14.1 minutes, okay, for it to reach a temperature of 80 degrees Celsius. Now, part 3. So part 3, they want us to express t in logarithmic form. So basically what they actually want us to do here is to be able to rearrange the equation. So now, okay, t, if t is to be in logarithmic form, I suggest you just flip the equation. So theta equals to this. Why don't you say that this is equals to theta? So straight away, when our t, which is what we want to make the subject of the formula here, is on the left hand side itself, it makes your life slightly easier. So I minus 10 from both sides of my equation. I will get theta minus 10. Then what I can do here is this: 2.4 the power of t over 8 is equal to theta minus 10 over 15. Okay, now what I can do is to express this in logarithmic form. So this is index form, so the base is 2.4. If I were to express this in logarithm form, what I get is logarithm of theta minus 10 over 15, base is 2.4. So the skill here I'm applying is changing between the index form and the logarithmic form. All that remains to be done is to resolve the 8. I multiply by 8 on the left hand side, multiply by 8 on the right hand side. Hence t equals to 8 logarithm of theta minus 10 over 15 to the base of 2.4. And I am done with example 27. Now, can you please pause the video and try 27, and when you're ready, unpause the video and I'll quickly go through the answers in 3, 2, 1. Okay, now first and foremost, at the first part, they ask you what is the temperature 5 minutes later. So this one simply, my t value equals to 5. You sub it in, you find that the temperature is 65.2 degrees Celsius. I think that one is just basic calculator skills. You should find it quite doable. So for part 2 itself, find a time when the temperature is 50 degrees Celsius. So remember that the formula is given by t is equals to 27 plus 58 to the power of 0.92 t. So I'm actually substituting t to be equals to 50 over here. Then what they have done here is 50 minus 27 and divide by 58. I get this. Then we take logarithms on both sides of our equation. Apply the power law, hence the t comes here. And finally we get this value, this line here where t is equals to log of 23 over 58 divided by log of 0.92. So it's 11.1 minutes when temperature is 50 degrees Celsius. Last but not least, similar to what we've done in the previous example, t minus 27 divided by 58, okay, is equals to 0.92 t. I express my index form in logarithmic form. We will get this, and this actually is shown. And that's it for 5.5. Thank you.